Okay, welcome to this 5-minute lesson on introduction to 2's complement. And you can see here this URL, all the links and resources from this presentation are in there for you to do some work. So, first things first, have a go at this, see if you can match the correct names with the flowchart shapes. Okay, so hopefully we've got this correct. So input output is the parallelogram, starting end is the oval, process is the square, and the decision is the triangle. So obviously the process is doing, like a workout calculation, and the decision is like an if statement or a loop within a flowchart. So today we're going to look at signed and unsigned numbers within binary. So within binary we have positive and whole numbers, integers. So again, we can have these those positive and negative. So we can do the same in binary. So one method we use in that is called the most significant bit, which is the furthest most left-hand bit. So if you look on here, this one here, this one represents the number to be a minus number. If it was a 0, it would represent it as a plus. So with this method, the final bit is taken out. So it means the maximum positive numbers is 127, but you can have 127 minus numbers plus 0, so you still have the same number of combinations of 256. However, there are some issues with the unsigned numbers because there's two representations of 0. Because you can have all these zeros and a 1 and 0, and also when we do binary addition, it gives the wrong output, which is really negative. Due to that, 2's complement is used to represent the negative numbers in binary. So the way the first two is find the 2's complement number, Denary to convert to binary, flip the ones with zeros, and then add Denary 1. So I'm going to talk you through a quick example here of how to do that. So if we're going to try and figure out the binary number, let's say 15 in binary, so I need to figure that out the Denary number 15 in binary, so we do 1, 2, 4, 8, 16, 32, 64, 128. So it'll be 0, 0, 0, 0, 1, 1, 1, 1. So step 1, we figured that out. The next step, we flip all the 1s to 0s. This will be 1, 1, 1, 1, 0, 0, 0, 0. Then we add Denary 1. So this is adding Denary value of 1. So this will be 1, 1, 1, 1, 0, 0, 0, 1. So minus 15 in 2's complement is 1, 1, 1, 1, 0, 0, 0, 1. So the key part for this, which most people get wrong, is this adding Denary 1. So not adding a 1 to the end, it's a Denary 1, because this here is Denary 1. If there was already a 1 here, for a different number, it would become a 2, and then our places up where it is, so we've got our placeholders at the top. 64, 128, so it'd be 0, 0, 1. 0, 0, 1, 1, 0. So that would be 38. So now once we've got our number, the first thing is we do is we flip, so we do our 1s become 0s, and our 0s become 1s. And then now what we need to do is add Denary value 1. So you can see there's a 1 in this placeholder here, but this needs to become 2 because we're plussing Denary 1. Yeah, that's the key thing with Denary 1. So this 1 needs to become 2. So for this, what we have to do is this one here will become 1 because that's there, and this becomes 0. So minus 38 will be this number in binary. 0 here. So if we want to do the other way around, so 2's complement to Denary. So let's say we had a number already in here. Let's do this. So this number here. What the first thing we do is flip again. So we do it the other way around. Like so. And then what we would do is add Denary 1 again. So we'd add Denary 1. So again, when we think about Denary 1, it's this placeholders. 128. So here we can't add a 1 at the end, so all these would add up. So 4 plus 2 plus 1, yeah. would then, plus another 1 would then become the 8. So then these would be zeros. Yeah. So this number here is the positive number, so we know it's 8. So this number here in 2's complement would be minus 8. So have a go at the worksheet, and there's some questions there to give it a go. Okay, hopefully you complete that worksheet and done some nice little notes for your revision. These are the answers to the questions just to check how you've got on. These are some additional resources and reading around the topic to support and help you. And we're just going to go through a quick exam question. So I'm going to pause it, have a go at doing this. Okay, so we've got this, we need to work it out into minus 6. The first thing is to convert it to a binary. So 2, 4, 8, 16, 32, 64, 128. So 6 would be. Okay, this is an exam question based on 2's complement. So what I'd like to do is have a quick read, pause it, give it a go. Okay, welcome back. So we're going to talk through this exam question. Hopefully we've all got it right. So the first thing it's asking for is plus 6. So we need to do our little placeholders for binary. 128. So 6, so it'll be 0, 0, 0, 0, 0, 1, 1, 0. So that will be the first mark because we've got it in plus 6. So now we need to do our 2's complement. So step 1, we need to flip it. So all the 1's become 0s and 0s become 1s. So yeah, so we've got 1, 1, 1, 1, 1, 0, 0, 1. Then we need to add Denary 1 to this. So then this 1 will become 2. So it'll be 1, 1, 1, 1, 1, 0, 1, 0. So that's minus 6. 0, 1, 0. It's down to there. And then compare these two features. So the first thing is sign and magnitude is 2 representations of 0, which obviously you can't have as a computer system. And secondly, when you do binary addition using sign and magnitude, it gives you the wrong results. So that's the answer to those questions. Okay, I want you just to pause the video, 60 seconds, write as much as you can do about the binary topic that we've been covering. So that's hex, binary shifts, 2's complement, binary addition, everything, just a little recap.